Hi everyone, very good evening and welcome back to Geeks for Geeks practice. Please give me a +1 in the chat if my voice is clearly audible to everyone and everything is working fine. Then I will share my screen and we'll start with the problem. Hi Madbar Joshi as well. So today's problem is really interesting and I have two solutions for them. So that is why it's going to be very interesting. Hi Ruchin and hi Madbar as well. So let me quickly share the screen and then I will discuss the problem with you as well. Okay. I hope that the audio and everything is fine. And if you can see me and everything is fine, then you can make sure to hit the like button. So basically, this was the problem of the day for yesterday. That is Wi-Fi range. Okay. So what does the problem say? The problem says that we will be given a string which will be representing n rooms, right? Given a string whose size will be n. Okay, and we'll be given a string s, right? In this string s that we have been given, if s of I is equal to 1, then this means that there is a Wi-Fi in this particular ith room. Okay, and if this ith room has a Wi-Fi, now let's suppose there is a ith room that has got Wi-Fi, so it has a range of x. Okay, x also has been given. Okay, x is the range of the Wi-Fi. It will be both on the left and the right. So if there is a Wi-Fi in the ith room, then it will cover x range on the left side and x range on the right side. So basically you can say I minus x till I plus x, that will be the range. Please write +1 in the chat. Is this part clear? That from I minus x till I plus x, the Wi-Fi will have its range. Okay, that is one thing. Now if any ith room does not have a Wi-Fi, then si will be 0. So it represents that there is no Wi-Fi. So each Wi-Fi has a range x, as I have told you. So it will cover till I minus x and I plus x. Now what we need to do is we need to find that whether all the students can use this Wi-Fi or not. Okay, so we have to check that overall all the n students that are there, whether they will get the Wi-Fi or not. So is this much part clear to everyone? Hi Shreya as well. So is this much part clear to everyone? Please write yes in the chat, guys. Are you all clear with this much part? Okay, the like please write I minus x I plus x. Okay, if there is a Wi-Fi in the ith room, okay, so if si is equal to 1, then its range will be I minus 1 I plus sorry I minus x till I plus x, right? And sometimes what can happen is like I minus x can go negative also, right? So these things can happen. Now if I have to see this thing, so this is what this is again. If you remember, right, if you remember this thing, so again what I can do is, in order to solve this problem, I can use the line sweep algorithm that I have told you a few lectures before in one of the problems, right? So we can do what we can, if you are watching the PODs regularly, so I have told in one of the problems the line sweep algorithm. Okay, so I can say that the left range is going to be what the left range, like like basically what I have to do, all the elements from the range I minus x till I plus x, they will be increased by 1. Okay, they all will get Wi-Fi, right? All the elements will get Wi-Fi, so they all have to be increased, right? So in that case I can say that, okay, what I will do is P of L plus is equal to 1, and P of L is this I minus 1, and R is what I plus 1. So P of R plus 1 minus is equal to 1. So I'll subtract R plus 1 by minus 1. So is this point clear to everyone, right? Please write line sweep or +1 in the chat. Does it make sense that using the line sweep algorithm and doing this, P of L plus is equal to 1, and P of R plus 1, like R plus 1 minus is equal to 1, right? So that is what we can do, because if we want to update a lot of ranges again and again, so that is going to take time. So instead of that, what we can do is we can use this prefix sum technique, that is line sweep algorithm, and that will help us to update all the ranges very easily. Is this part pretty much digestible and clear to everyone or not? Please write yes in the chat. Does it make sense that if the ith room is having a Wi-Fi, then my leftmost range can be I minus x, rightmost range can be I plus x. So I want to increase all the p, like all the students in this range will be increased by 1 kind of, right? So they all will become positive by 1, they all can increase by 1. So I'll say that, okay, P of L plus is equal to 1 and P of R plus 1, that is right plus 1, is equal to minus 1. So is it clear to everyone else also, like this particular technique, line sweep? Please write yes, and you can hit the like button as well. That is what we can do in the very first basic step, right? And then in the end I can check that if even after doing this, if any of the like student is not getting Like after this I can run the prefix algorithm. Okay, I can take the prefix sum overall, and I can check if there is any index that is still 0. So that means that this will mean that that student is not getting that Wi-Fi. Okay, so this point is clear to, I think, everyone, right? So I hope that it is clear. Please let me know, guys. Yes or no? Is it clear? So what we can do first of all here is we can have a vector. Let's say vector of int, and let me name it as prefix. And I can have n indexes. Initially, all of them will be marked as 0. Then what we can do is we can say that for we can say that int I starts from 0. Okay, I is lesser than n. That is the total number of students, total number of indexes. And then what I will do is, if the ith student has got a y, like if the ith like if the ith place has a Wi-Fi, right? If s of I is equal to 1, if it has a Wi-Fi, then I can say that what will be the left range. So left range can be equal to nothing but I minus capital X. Okay, and the rightmost range till which the Wi-Fi can be available is what? The rightmost range in this case will be I plus X, right? I plus X. Okay, that is going to be the scenario. Then after that, what do? We normally do prefix of left plus is equal to 1, and prefix of right plus 1 minus is equal to 1. Okay, that is what we do. But in this case, we have to take care of something more. Okay, like it might happen that let's say you are having your left. Okay, let's say we are having our left is equal to I minus X. Okay, and let's say the I value is something like 2 and the X value, let's say, is something like 5. Then what will happen now? 2 minus 5 will be negative. Okay, so I cannot have a negative index in the array, right? Because this might become minus 3. So that is why I will keep a check here. Okay, I will keep a check that if let's say the left is greater than equal to 1, if it is greater than equal to 1, then very easily I will say that prefix of left plus is equal to 1. Okay, otherwise what I will do is, if it is if its range is going to be negative also, let's say, as I said, if I is equal to 2 is there. Okay, and the range of this Wi-Fi is 5, so it will go from here till the minus 3 index, right? So I will make all the increments on the 0 only. Okay, so that is what I'm going to do, because the negative index is minus 2, minus 1, all these are not going to be available to me, right? So that is why what I will do is I'll increase these indexes up. So that is why what we will do is, else we will say that prefix of 0 plus is equal to 1. Is that clear to everyone, guys? Please let me know. Okay, is this much part clear to everyone, right? And similarly I will say that, okay, if the right plus 1, okay, if it is lesser than n, if it is lying in the range of my prefix array, then I will say that prefix array of right plus is equal to sorry, right plus 1 uh, plus is equal to minus 1. Okay, so I'll decrease it by 1. That is what I'm going to do. And after that, what I will do is I'll take the prefix sum overall. Okay, so I starts from 1, I is lesser than n, and then we will do an I plus plus right here, and we will simply do what? Prefix of prefix of I plus is equal to prefix of I minus 1. That is what we are going to do. And in the end, what we will do is we will simply say that, okay, let's start our I from 0. I is lesser than n. Okay, then we will do I plus plus right here. And once that is done, so we will simply check that if there is any if there is any position that is still 0 after the line sweep algorithm has taken place, then I can say that this ith student does not have a Wi-Fi. So all students do not have Wi-Fi, and I will return false. Otherwise, if I never return false, then I will return true in this case. Is this much part clear to everyone? Please write yes in the chat, guys. Does it make sense for everyone? I'm just using the line sweep algorithm feature here. Okay, so let's try and submit it and see if it gets accepted. I hope it will get accepted. And it does get accepted, right? So this particular approach is getting accepted. Is it clear to everyone? Ruchin is clear with this approach. What about other people? Other people, if you are also clear, then you can hit the like button and tell me in the chat. Okay, basically if I have to like see, I can say that if the if the ith place has got a Wi-Fi, then its range will be from I plus X in the right till I minus X in the left. Okay, so that is why what I can say is line sweep algorithm, yeah, that is basically, yeah, this is the left and this is the right part. Okay, so I can say that if I have to update, like in this range I have to update everybody as plus 1. So if I will do it manually, so that is going to take for one position it will take order of n time. Okay, for one I. So for n indexes, it will take order of n square time. So instead of that, what we can do is we can use the line sweep algorithm, And in the line sweep algorithm, we can always say that prefix of left plus is equal to 1. Okay, and if the prefix of right is available, so prefix of right plus is equal to, you can say, minus 1, right plus 1 basically, sorry. Okay, so that is how the line sweep algorithm works, and that is how it can be done easily, right? Is this part clear to everyone? Please let me know in the chat, guys. Is this part clear to all of you? Then I will move further to the other solution also. But this approach is going to take order of n space, so we have to remove the order of n space also that we are taking, right? So we can try to remove that as well. Okay, just give me a second. I'll generate the link for this one. I hope it will generate the link. Okay, so yeah, the link is generated. Now I will just share the solution one. Okay, this is the very first solution that I have shared, and this is the line sweep, basically the line sweep approach. Okay, line sweep approach. Is this much part clear to everyone? Let me walk you through that again, so that we can just have a look at these things again. Okay, so what I am going to do is, as I said earlier, like if the ith place, if the ith index has got a 1. Okay, so if it has a Wi-Fi, then the range of that Wi-Fi will be from I minus x till I plus x. Okay, so that is why we are doing what, left plus is equal to 1 we will be doing. So we will check if the left is greater equal to 1, then we will do left plus is equal to 1. Otherwise it might happen that the left might come negative as well, so we don't want to do prefix of left plus 1 plus is equal to 1 always, because left might become negative also. If let's say I is 2 and x is 5, then it might become negative. So in that case we will put all the things on 0 only, so prefix of 0 plus plus instead of doing prefix of left plus plus. And I'll check if right plus plus is available, right plus 1 is available, then I will say prefix of right plus 1 is equal to minus 1, so I'll decrease it by 1. Then I take the prefix sum, then I check if there is any index that is still 0, so this means that it has not received the Wi-Fi, so the ith student is not having the facility of Wi-Fi. Then I'll return false, otherwise I'll return true. So if this much part is clear, then please hit the like button and give me a +1. Then I will proceed further with the code part. Okay, can we proceed further, guys? Please write yes in the chat if this much part is clear to everyone. Then please let me know. Is it clear to everyone? Then I can proceed with the optimal part, right? Currently the approach that I have discussed, that was the line sweep approach, it had a time complexity. Okay, my approach had a time complexity of kind of, you can say, order of n, and the space complexity of my approach was also order of n. So can we optimize this to order of 1? That is the challenge that is lying ahead of us. Okay, so please give me +1, guys, and then we will proceed further. Even if you did not know the line sweep, so now you will understand the approach. Okay, so we have to try and make the space complexity as order of 1. Okay, so that is what our target is. So how can we do this? We can do this with the help of some observations, right? So what I can do here is, let's take this particular example itself, right? So what I can do is, I can always have a range variable. Okay, initially I can have a range variable. Let's say initially I'll mark it as 0. Okay, and what I am going to do is, in this case, if let's say if I take this example, so in this example it is what, 1 0, and then I have another 0, then I have 1, and then I have the 0. Okay, so I'm going to take a range variable that is going to tell me that whether my Wi-Fi is having that much range or not. Okay, so here the x value is what, x value has been given as 1. Okay, so I will come to this particular place. Okay, when I come at this particular index, so I see that okay, there is a Wi-Fi. So the whatever is the range, I'll update, whatever is the x value, I'll update my range to that. So I'll update my range to 1. Okay, because the x value is 1. Then after that I will move to the next index. Okay, so I move to this index now. When I move here, so this is 0. Okay, if it is 0, like basically what I'm saying is, if it happens that s of I is equal to 1, okay, is equal to 1, then we can mark our range as x. Okay, we can say that okay, x is our range because we are having the Wi-Fi. Otherwise we can say that we can decrease our range by 1. It can become negative also, I'm okay with that. Okay, so in that case what will happen, we are having a 0, so we don't have a Wi-Fi here, so I will do range minus minus. When I do range minus minus, then range becomes 0. It should never become lesser than minus x, understand this. Okay, then after this what will happen, when I move to the next index, so I will move here, right? When I move here, so is it 0? Yes, it is 0. So if it is 0, then again I will reduce the range value, because I'll go to the else part. Then the range becomes -1. is this value lesser than minus x? No, it is not less than minus x. So this indicates that if it will become less than minus x, now the moment the range value becomes less than minus x, so it indicates that I am not able to reach till that point. Okay, understand this thing. So here what will happen is, then after that I move further. So when I will move here, so I reach one, like I get a 1. So I'll say, okay, let's update our range to x only. So the range gets updated to 1. Then after that what happens is, I move to this particular index. So I move to this particular index, that is 0. So again I will reduce my range and the range becomes 0. Okay, so this is how I can say that in the end, if the range did not become negative even after traversing, and then I'll move forward here. So the range did not become negative. So I can like see, if I'm iterating and if the range becomes less than minus x, then I'm going to return a false. Or if the range, after iterating throughout, if the range becomes 0, then also. So is this much part clear, that for this one, I will simply say that okay, it was possible for us now, because if you see, so this particular guy can cover this guy, okay, and this particular Wi-Fi can cover here and here. So everybody is covered. So that is why we are ultimately returning 1. That is true, because Wi-Fi is available. So all the rooms have the Wi-Fi. Is this much part clear? Please write true in the chat, yes in the chat, and then I will proceed further with the furthermore part. Okay, is this much part clear to everyone? Please write yes in the chat, guys. Okay, now let's understand another example. Let's say that if I have the x value as 3, and I have some example of this sort. Let's say if I have, let's say an example where I have something like 0. Okay, then I have 0, then I have 1. Okay, after that let's say I have 0, 0, 0, 0, 0, and then I have 1 and all those stuff, right? If I have this thing, so if I have something of this kind, then in this case what will happen? So initially I will have my range. Okay, so range will be initially 0, and as I have said, if the ith string, if the ith index, if the ith character is 1, then what I will do is I'll update the range to x. Okay, otherwise what I will do is, else I will update the like I'll decrease the range. Okay, and the moment range becomes lesser than minus x, that is when I will reduce. Why? Because if you will see here, so I come here. Okay, so when I come at let's start our iteration for this test case. Okay, let's see, if you reach this index, so this is 0. So what will you do with the range, Madbar and everyone else in the chat? What will I do? What will I do with the range? Please tell me. Please tell me. Can you look at the scenario and tell me what I will do here? Okay, I will decrease the range by 1 because this is 0. So the range decreases by 1, so range becomes minus 1. Okay, then after that I hope that the everything is working fine. Okay, a lot of us are a lot of you are watching us, so guys, please hit the like button if you haven't already. Okay, so yeah, this will become minus 1, right? Then after that, when I reach this guy, okay, then again I will decrease the range, so it will become what? It will become minus 2. Okay, so the moment the range become lesser than minus x, then I will start worrying. Okay, I will tell you more about that. So this range is minus 2, so still things are fine for us, right? After that, when I move to the next index, so I move to this index. Okay, when I move to this index, so I can see that the ith index is having 1. So in that case, I'll update my range to 3. Okay, so the range gets updated to 3, and the moment it gets updated to 3, so this basically indicates that I can go 3 in the left side and 3 in the right side, kind of this thing. Please write agree in the chat. Okay, do you agree with me on this point? Right, I can have 3, like it can reach 3 on the left and 3 on the right. Okay, that is what is going to happen. Now in this case, when I will proceed further and when I reach here, so what is the scenario? I'll get a 0. So since I get a 0, so I'll decrease the range, so range becomes 2. Okay, then I proceed further, then I move to this particular index. Again it is 0, so I reduce the range by 1 more, so it becomes nothing but 1 here. Okay, because it was 3 here, then it became 2 here, 1 here. Okay, then after that, when I reach at, let's say, this particular place, then again I can see that it is coming, so I will mark it as 0 now. Okay, the moment it becomes lesser than minus x, then I will be worried. So let me put some more zeros here. Okay, and then I will put 1. Okay, now after that, when I will proceed further, so I will move to this index. So the moment I move to this index, so I'll mark it as minus 1. Okay, because the range keeps on decreasing, so it becomes minus 1. Because basically, if you observe, so this one was able to cover this much range. Okay, this one was able to cover this much range, and now I've started to worry. So this is minus 1. Okay, then after this, what will happen here is, if you will observe, then I move to the next index. Again I see a negative value, so sorry, a 0. So I'll decrease the range, so it becomes minus 2. Then after that, what will happen? I'll again move forward. So I move to this index. Again, it is 0. This value is 0. So I'll decrease the range to -3. So is this much point clear to everyone? Right. Is this much part clear to everyone or not, guys? Please let me know. Okay. So the moment it happens that it is still -3. So it is still controllable. Okay, because if you see, so there are three index that are not that are having this -1. So suppose if there was a 1 here, okay, if there was a 1 here, then this 1 would have covered everything. That is why if the range is -3, then I can afford it. Okay, if the range is negative, and it is like if it is till minus x, then I can afford it. Okay, because if we had a 1 here, then this 1 would have covered everything. But now suppose that because if we had a 1 here, then the 3 range on the left would have been covered, so I would have been happy, right? But so that is what I'm saying, that if it happens that the range becomes lesser than -x, okay, lesser than -x. So if it becomes like if it becomes -4 or something like that, then I will start worrying. Because if it is -3, so I can say that, okay, if I get a 1 here, suppose in future if I get a 1 in this index, then all of this will be covered, so I don't need to worry about that. But suppose that if I get a 0 here, then what happens? If I get a 0 at this index, right, then the range will decrease by much more, and it will decrease to -4. And I can say that even in future, if I get a 1 here, then it will be only able to cover this much segment. So I cannot give the Wi-Fi to this particular student. So that is why I am saying that if the range becomes lesser than -x, okay, so if range is -4, if it becomes lesser than, which is like -4 is less than -3, okay, if the range, okay, if it becomes lesser than -x, then that is when I will start worrying. Is that part clear to everyone? Guys, please write yes in the chat. Is this much part clear to everyone? Okay, please write clear in the chat, guys. This part is clear. So that is one thing, that if the range becomes lesser than -1, then I will return false. That is one thing that I can say. Now another thing that I can like so I hope that this much part is clear. Please write yes in the chat. A lot of you are watching, guys, so you can hit the like button and tell me if you are clear with this part or not. Is everyone clear till now? Please hit the like button and write yes in the chat. Is this much part clear? If I see that, okay, I is equal to 1, then I'll mark the range as x. Otherwise I'll decrease the range. And the moment the range decreases lesser than -x, then I'll be unhappy. Okay, so this much point is clear. Now there's one more perspective that you need to look at. Okay, so suppose if we follow the same algorithm on a different kind of string. Okay, so suppose if the string looks something like this. Okay, if suppose this happens, right, so yeah, suppose this thing happens. So suppose initially your range is what? Initially your range is 0. Then what will happen is, first of all, you are at this particular index. Okay, so in this case you will mark it as -1. Okay, fine. Now you come here and you see that, okay, it is again 0. So you will decrease the range again, so it will become -2. So you are saying that you need some Wi-Fi here. Okay, then you come here. So you can see that this guy will cover the range of 3. So that is why you are very happy, and you will say that, okay, everything is fine for me, so the range will become 3. Because I can say that, okay, the left side is totally covered, I'm fine with that, I'm okay with that. And let's put it as positive 3, because the next 3 also, if they are, even if they are 0, so I will be able to encounter them. Okay, I'll be able to go through them. Okay, please don't make any other sense of encounter word. Now what we will do is we'll proceed further, and then I come to this 0. Okay, so I will mark the range decreased, range will become 2. Okay, then I come to this index and I will decrease the range, it becomes 1. That's fine. Then I will come here and again I see 0, so I'll decrease the range, it becomes 0. So basically I can say that if there was a Wi-Fi here, so 3 indexes were covered here and 3 indexes kind of were covered on the left side. Now I can say that this student does not get it. Okay, so if you will see, if I proceed further, and here I am, right, so again the range decreases. So after coming out of the loop, if the range is negative after the loop, okay, understand this thing, after the loop, okay, after the loop, if the range is kind of negative, if the range is negative, then in that case I have to return false, because I can say that the students are not getting the Wi-Fi, because I can simply see here that if this guy has a Wi-Fi, then it will cover till here and all this part, but this student is not going to get a Wi-Fi. Okay, if there were other students also, so they will not. So if after coming out of the loop, if the range is negative, so this means some student at the end did not get the Wi-Fi. Is that clear? So there are many scenarios in this particular order of n approach also. So does it make sense for everyone? Please write yes in the chat, and then I will proceed further, right? So after coming out of the loop, that is what I have to see. Okay, so let's do one thing. Let's start writing the code for that. So initially I'll declare, let's say something like int range. So Madbar is clear. What about other people? Other people are also clear. So initially I'll mark the range as 0. Then what I will do is I will simply start my iteration. So I starts from 0. Okay, and I is lesser than n value, and then I will do an I plus plus right here. And what I am going to do is, if it happens that let's say if it happens that s of I is equal to 1. Okay, if it's a 1, then this means that I will update the range to x, because if like I'll update the range to x, because even if the left was negative, so I have kind of given it wi-fi. Otherwise what I will do is, otherwise I'll decrease the range. Okay, and then in this case what we can say here is, if it happens, right, if it happens that the range becomes lesser than minus x, if it becomes less than minus x, please write minus x in the chat. If it becomes less than minus x, so this means that on the left, like I cannot provide some wi-fi, right, for some students. So that is why what I will return from here is, let me write return statement. So I will return false at this particular point. Okay, otherwise what I will do is, in this part, if it like after coming out, if the range is negative, okay, so if it's negative, in that case also I will return false, because I'll say that some of the students will not get it, as I've explained. Otherwise in the end I can simply return the true variable, that true value. This will indicate that all of the students are getting the Wi-Fi. So this is what I've explained. Order of n approach, very simple and cute approach compared to the earlier line sweep algorithm. Is it clear to everyone, guys? Please write yes and hit the like button as well if everyone is clear with this part. I hope that it makes sense for everyone, right? I have done a dry run on sample test, some test cases of my own also. Let's try and compile it. I hope that it will get accepted. It does seem to get accepted. Yeah. So this also gets accepted. Let me try and give you the code. So Madhva Joshi, which approach did you submit yesterday? Can you tell me that? And you can write got it in the chat as well, Madhva Joshi. Okay. Second wala easy hai. Which one did you try? Which one did you submit yesterday? First one is also easy, man. First one is line sweep algorithm. Okay, so yeah, this is the code, and let me write second approach. Okay, and then I will paste this link also. So yeah, I hope this is also visible in the chat section. All right, and talking about the time and the space complexity of this code, so I will say that the time complexity of my code, if you will see here clearly, the time complexity of my code was nothing but it was order of n, because I was iterating throughout the string, and the space complexity was order of 1 because I was just using a range variable. Okay, so that is how I optimized it. This is kind of, you can say, the second approach. Okay, let me write it as second approach. That was space optimized, right? This was the second approach. And as I said in the first approach that I had written, first approach that I had done, in that approach the time complexity was order of n, and the space complexity was also order of n. Okay, so this was the line sweep approach. Okay, line sweep algorithm, you can say. If you don't know, you can read about it more. And another thing that I want to summarize before, so this is kind of a code forces problem, you can say code forces b, I can say. Okay, this is kind of a code forces b problem, and also I can say it can come in the online assessment of some companies. Okay, so this kind of problems you should always try to solve, so that always you are prepared with such things. Okay, so I hope that you understood the problem for today. Okay, and you liked it. Did you understood, everyone? Right, I think a lot of people are still watching us. So did you understood it, everyone? Yes in the chat, and then I will end this session. Okay, I'll wrap up. Got it. Okay, so Madbar is saying that he has got it. Okay, so I hope other people are watching from CP44 batch. So that is very good. So Madbar has got it, other people have also understood it, I think. So that's it for today, guys. Thanks a lot for joining. I hope that you understood this and enjoyed this live session. Till then, good night everyone, and keep coding, keep solving the problem of the day. Tomorrow Abhinav will be taking the session, so make sure to join it, and I'll see you with another problem of the day on the next weekend. But I will also see you with the weekly contest on Sunday. So let's meet then. Till then, goodbye and take care, everyone. Keep coding, guys. Bye.